Hi to everyone, myself Dr. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today I am going to discuss about Introduction to Corrosion and its effects. In this session I am going to cover these topics: what is corrosion and its definition, causes of corrosion and what are the consequences of corrosion, and classification of corrosion. And the classification of corrosion, two types you have to see. One is dry or chemical corrosion, other one is wet or electrochemical corrosion. In this session I am going to cover all these topics. Before going to this topic, we should know the corrosion. What is the corrosion? Corrosion nothing but it is a natural process. It is occurring in nature, spontaneous, that causes the transformation of pure metals into undesirable substances when they react with the substance like water or air. What is corrosion? Corrosion is a natural process when pure metals reacts with water or air. Metal forms undesirable products like oxides or chlorides. Then it is called corrosion. What is corrosion? When the pure metal reacts with water or air, it forms undesirable products. Then that is called corrosion. The surfaces of almost all the metals begin to decay more or less rapidly when exposed to atmospheric gases like water or other reactive liquids mediums. When pure metal surfaces like metal is there, when this pure metal reacts with water or air, it undergo corrosion and decay of metal takes place. This decay may be, some metals have undergo corrosion very rapidly, some metals undergo corrosion very less intensive. Depends upon the nature of the surface. The rusting of iron involves the formation of iron oxides Fe3O4 via the action of atmospheric moisture and oxygen. Iron undergo corrosion by forming Fe3O4. When iron reacts with water and atmospheric oxygen, it forms Fe3O4. We call rusting of iron. Iron reacts with water and oxygen, atmospheric oxygen, forms Fe3O4. Iron oxide is called rusting of iron. Similarly, formation of green film on copper, on the surface of copper. This copper metal is there, on the surface it forms green color film. That is, green color film is copper carbonate plus copper hydroxide. Copper reacts with carbonates and water, it forms copper carbonates and copper hydroxides. On copper metals, it is in green color. These two, copper carbonate and copper hydroxide, forms corrosion in copper that gives green film on the metal surface of copper. What is the causes of corrosion? Why the corrosion occur? We'll see. This is the earth. This is earth crust. In this earth crust, all the metals are existed as metal oxides like MO2 and metal chlorides like metal chlorides and silicates, metal SiO2 and metal carbonates, MCO2s and metal sulfides. Okay, na? All the metals are available in earth crust like metal oxides, metal chlorides and metal silicates, metal carbonates and metal sulfides. The metal exists in nature in the form of their minerals or ores. Metals in the form of ores or minerals, they are available in earth crust. In the stable combined forms in the earth crust, these are the very stable forms of the metals in the earth crust. These are available in ores or minerals. Okay. During the extraction of the metals, these ores are reduced to metallic state by supplying considerable amounts of energy. What I said, metals are available in earth crust like metal oxides and metal chlorides. Means these are in form of salt forms or ionic form. Metal existed in ionic form in the earth crust. To get pure form like metal, we have to reduce the metal plus 2 ions by supplying some energy. Means we have to supply some electrons to these, then this metal ions reduce to pure metals. Okay. When metal plus 2 ions are existed in earth crust, means metals are available in earth crust like metal oxides and metal chlorides in the form of M plus 2 ions. we have to reduce to get pure metal. We have to supply some energy to get pure form from metal paste to ions. During the extraction of metals, these ores are reduced to metallic state by supplying considerable amount of energy in the energy supplied in the form of electrons. Hence, the isolated pure metals are regarded as excited states than their corresponding ores. Ores having some energy. In ores, the metals oxides or metal sulfates having some energy. When we supply some electrons, these metal get pure form and these are in excited state. So, the pure form of metal is in excited state. So, these excited state metal always try to get ground state energy. To decrease the energy, the metal undergo oxidation and again it will form to metal oxides and metal chlorides to get stable form. Hence, the isolated pure metals are regarded as excited state than their corresponding ores. Compared with ores, the pure metal have highest energy. So, metals have natural tendency to go back to their combined states. So, these pure metals always trying to get the ore form or mineral form. When metal is exposed to atmospheric gases or matter and liquids, etc., and the metal surface reacts and forms the more thermodynamically stable compounds. These pure metals reacts with atmospheric gases like oxygen, CO2 or any other gases like sulfides and moistures like water, liquids, any other liquids. These all together combine and reacts to form more thermodynamically stable compounds, forms metal chlorides or metal sulfates and metal oxides, metal carbonates. These are the thermodynamically stable compounds. So always pure metal trying to get corroded and to get salt form or oxide forms. What are the consequences of or effects of the corrosion? If corrosion occurs, what happens? What are the consequences we will get? Consequence of corrosion cause a great loss of economy. Loss of economy you can observe by the corrosion, and life of machinery will decreases by the corrosion. The following harmful effects are specific. These are the very specific effects by the corrosion. Loss of efficiency. The machinery lifetime will be decreases with corrosion. The valuable metallic properties like conductivity, malleability and ductility extra are lost due to the corrosion. Metal contains some properties like conductivity, malleability, ductility. After corrosion, these all properties will be decreased. So, the valuable metallic properties lost due to the corrosion. Lifespan and efficiency of metallic parts of machinery and fabrication is reduced. The lifespan of pure metal will be decreased after corrosion. The contamination of product. This is a machinery. They are made up of metal. If it is corroded, if the product, any liquid is flowing on this product will be corroded. The loss of valuable material, the contamination of product will be occur due to the corrosion. The contamination occur due to the corrosion. Loss of valuable materials such as blockage of pipes and mechanical damage of underground water pipes. Due to the corrosion, the metals made up of with metals, the pipes are made up of with metals. These undergo corroded. So, due to the corrosion, these pipes get blockage occurs in these pipes and mechanical damage occur in the underground pipes. Accidents due to the mechanical loss of metallic bridges, cars, aircrafts. All the bridges are made up of with metals. So, if the metal will get corroded, then the lifetime of this metal decreases and the accidents will take place. Though this is the great loss of corrosion. Causes of pollution due to the escaping products from corrosion. While metal reacts with some gases like oxygen, CS2, this releases some undesirable product and releases some poisonous gases. So pollution occurs due to these escaping products from the corrosion formation. Classification or theories of corrosion. How many theories are there in corrosion? We'll see. Based on the environment, corrosion is classified into two types. Based on the environment, corrosion is classified into two types. One is dry or chemical corrosion. Second one is wet or electrochemical corrosion. First one is dry or chemical corrosion. Second one is wet or electrochemical corrosion. What are the difference between dry corrosion and wet corrosion? We'll see. First one is dry corrosion occurs in dry condition. Dry corrosion occurs in dry condition. Wet corrosion it occurs at wet conditions, like in presence of water or moisture. The wet corrosion will take place. Second point is, if the corrosion takes place due to the direct chemical attack in the absence of moisture, corrosion is known as dry corrosion. If metal is there, it directly reacts with some acids or gases directly. There is no involvement of moisture in this dry corrosion. In case of wet corrosion, the corrosion takes place due to electrochemical attack in the presence of moisture or conducting medium. Corrosion is known as wet corrosion. In wet corrosion, the metal reacts with some gases in presence of water or moisture is called wet corrosion. In this, electrochemical process takes place. The third point is, this dry corrosion explained by the absorption mechanism. The dry corrosion is explained in terms of absorption mechanism. But in wet corrosion, it was explained by electrochemical mechanism. In wet corrosion, electrochemical mechanism involved. In dry corrosion, absorption mechanism involved. It occurs on both heterogeneous and homogeneous surfaces. Dry corrosion occurs on metal surfaces, heterogeneous surface and homogeneous surface. But wet corrosion occurs in the case of heterogeneous metal surfaces only. Wet corrosion occurs on the heterogeneous metal surfaces only. Dry corrosion is uniform, means if it is metal there, uniformly corroded. Dry corrosion is uniform. Okay. In wet corrosion, the corrosion is not uniform. Not uniform means at some place corrosion is high, at some places corrosion is less. So corrosion is not uniform. In wet corrosion is not uniform. The dry corrosion is very slow process. It takes long time. But wet corrosion, it takes place very fast. It takes very less time. Dry corrosion products accumulate at the place where the corrosion occurs. If it is metal is there, if corrosion is occur, the corroded product will be there at same place. But in case of wet corrosion, the corrosion takes place at anode, but products accumulate near the cathode. If it is metal, here it is anode. If it is cathode, always corrosion takes place at anode, but this corroded product always will be there at cathode, near to the cathode. These are the difference between wet corrosion and dry corrosion. Now I am going to explain dry or chemical corrosion. This type of corrosion is due to the direct chemical attack of metal surfaces by the atmospheric gases such as oxygen, halogens, hydrogen sulfide, sulfur dioxide, nitrogen or anhydrous inorganic liquids. This type of corrosion is to the direct chemical attack of these type of gases is called dry or chemical corrosion. In this, there is no involvement of moisture. It's called dry or chemical corrosion. Example, silver materials undergo chemical corrosion by atmospheric hydrogen sulfide. If silver is there, it reacts with hydrogen sulfide. It forms Ag2S and water. There is no involvement of moisture in this case. This is the color of polished silver. When reacts with hydrogen sulfide and water, it forms silver sulfide and water. The color of this Ag2S is tarnished silver. The pure silver converted into tarnished silver by reacts with hydrogen sulfide and oxygen. Different types of dry corrosion or chemical corrosions. The corrosion is dry corrosion is three types. First one is corrosion by oxygen or oxidation corrosion. The dry corrosion is divided into three types. One is corrosion by oxygen or oxidation corrosion. Second one is corrosion by other gases like halogens and hydrogen sulfide, etc. The second one is corrosion by other gases. The third one is liquid metal corrosion. Third one is liquid metal corrosion. What are the different types of dry corrosions? One is corrosion by oxygen or oxidation corrosion. The second one is corrosion by other gases. And third one is liquid metal corrosion. The first one, I am going to explain first one. What is corrosion by oxygen or oxidation corrosion? Alkali metals like lithium, sodium, potassium, etc. and alkaline earth metals like magnesium, calcium, tin are rapidly oxidized at low temperatures. Alkali metals and alkaline earth metals at low temperatures, these undergo oxidation very fastly. At high temperatures, almost all metals except silver, iron and platinum undergo oxidation. At low temperatures, all alkali and alkaline earth metals undergo oxidation very fast. At higher temperature, except silver, iron and platinum, except these, all the metals undergo oxidation at higher temperatures. Mechanism we'll see. In this dry corrosion or oxidation corrosion, what is the mechanism involved? We'll see now. In oxidation takes place at the surface of the metal forming metal. This is metal is there. This metal undergo oxidation first. Means if two metals are there, it forms two M+2 ions and it releases oxygen. See electrons. It releases electrons. Metal undergo oxidation means the metal forms metal ions and releases electrons. This is the oxidation reaction of metal. The second one is oxygen is converted to oxide ion due to the transfer of electrons from metal. Metal releases electrons. These electrons transfer to the oxygen and oxygen takes electrons. It forms oxide ion, O-2 ion. See, N/2 moles of oxygen reacts with 2 moles of electrons. It forms N moles of oxide ions. The overall reaction is oxide ion reacts with the metal ions to form metal oxide films. The metal and half moles of oxygen forms 2M+N and NO2-. This metal and oxygen forms metal oxides. What happens in oxidation corrosion? First, metal undergo oxidation, forms electrons and metal ions, and these electrons takes from oxygen takes electrons from these metal ions and forms oxide ion. This metal and oxide form metal oxide. Metal plus oxygen gives metal oxide. This is the corrosion product. This is the process of corrosion by oxygen or oxidation corrosion. This is the metal. This is a pure metal. First, this metal undergo oxidation, forms metal plus N ions and releases electrons. Similarly, it takes oxygen from atmosphere. This oxygen converted into O2- by taking electrons from this metal and form this metal oxide film or metal oxide layer. This is the oxidation corrosion. Initially, the surface of metal undergo oxidation. I already explained. Initially, the surface of metal undergo oxidation and the resulting metal oxides. It forms metal oxide, which restricts metal oxide. Scale forms barrier which restricts the further oxidation. The extent of corrosion depends upon the nature of the metal oxide. This is the metal. This reacts with oxide ion and it forms metal oxide. Some part undergo corrosion and forms. This is the metal oxide layer. The extent of this corrosion, or the scale of barrier, this scale of oxide barrier depends upon the nature of metal oxide. The extent of corrosion depends upon this nature of the metal oxide formation on the metal or corroded surface. If the metal oxide is stable, first it forms metal oxide on the surface. If the metal oxide layer is stable, or metal oxide is layer is stable or metal oxide film is stable, then what happens? If the metal oxide is stable, it behaves as protective layer which prevents the further corrosion. This is metal, it forms metal oxide surface or metal oxide film on this. If it is stable metal oxide, it will not, it will prevent the further oxidation of this metal. Means it will protect this oxide layer, protect the remaining metal surface. If the metal oxide is stable, this metal oxide prevents the surface of the remaining metal surface. If the metal oxide is stable, it behaves as a protective layer. This metal oxide behaves like a protective layer and prevents the further oxidation of the metal. Example, the oxide films of aluminium, tin, lead, copper, chromium, tungsten, etc. are stable and therefore further corrosion is prohibited. The oxide films of aluminium, tin, lead, copper, chromium, tungsten, etc. These will form stable oxide films. So further corrosion will be prevented by these oxides in the case of these metal atoms oxides. Second one, if the metal oxide is unstable, if the metal is there, it forms metal oxide by reacting with oxygen. This forms some metal oxide. Then the oxide layer is formed, decomposes back into the metal oxygen, and oxidation corrosion not possible. If this metal oxide layer is unstable, what happens? This metal oxide undergo decomposes and forms metal and oxygen, and this metal oxide form again pure metal form. So there is no formation of corrosion product in this case. If the metal oxide is unstable, the oxide layer formed decomposes back into metal and oxygen. Oxidation corrosion is not possible in the case of metal oxide is unstable. If the metal oxide is unstable, this metal oxide undergo decomposition, forms pure metal and oxygen. So there is no possibility to take place corrosion, and that is the oxidation corrosion not possible in the case of metal oxide is unstable. The example for the metal oxide unstable corrosion layers, the silver and iron and platinum do not undergo oxidation corrosion. Why? Because the silver, iron or platinum oxides are very unstable. These will form metal and oxide from the oxide layer. The third one is, if the metal oxide layer is volatile. If the metal oxide formed is volatile, what happens? See, if the metal oxide layer is volatile, then the oxide layer is volatilizes after the formation of and leaves the underlying metal surfaces exposed for further attack. See, if there is a metal, it reacts with oxygen, forms metal oxide. Okay, this is the metal oxide layer. It forms. If it is volatile, what happens? This metal oxide undergo volatilization and it leaves from the metal surfaces. Again, if metal oxide leaves from the metal surfaces, then we will get pure metal. Again, this will expose it to the oxygen. Again, it will form metal oxide. Again, it is volatile and it will get evaporate. Again, it form metal and again it reacts with oxygen. Like this, total metal undergo corrosion. This causes continuous corrosion, which is excessive in molybdenum oxide. The excess is, see, this is observed in the molybdenum oxide. See, metal is reacts with oxygen, it forms metal oxide. This is volatile and evaporation of metal oxide takes place, forms pure metal. Again, it is the fresh surface for the exposure of attack of oxygen. Again, it forms volatile oxide surface. Again, it will evaporate, and like that, the continuously it takes place, and the total metal will be corroded. If the metal oxide layer is porous, what happens? We'll see. The oxide layer formed has pores or cracks. In this case, the atmospheric oxygen penetrates through the pores of cracks and corrode the underlying metal surface. This causes continuous corrosion till conversion of metal into its oxide is completed. If there is a metal surface, this forms metal oxide surface, reacts with gases, If the metal oxide is porous, means some cracks are there or holes are there in this metal oxide surface, the oxygen undergoes penetrating to these holes and cracks. This reacts, the pure surface reacts with this oxygen, and this underlying metal surface also undergo corrosion. The oxide layer is formed as pores or cracks. In this the case, atmospheric oxygen penetrate through the pores or cracks and corrode the underlying metal surface. This causes the continuous corrosion till conversion of metal into its oxide is completed. So, it takes continuously takes place, and the total metal undergo corrosion. In the case of metal oxide layer or layers are contain porous. The examples of this metal oxide layer is contain porous. Alkali and alkaline earth metals having forms porous metal oxide surfaces. Corrosion by other gases. Second one is corrosion by other gases. Corrosion by other gases like sulfur dioxide, carbon dioxide and HDS. The degree of attack depends upon the formation of protecting or non-protective films on the metal surfaces. When metal reacts with sulfur dioxide, carbon dioxide or HDS, the degree of corrosion depends upon the metal oxide are the thin film formed by these gases, or depends upon the metal. When metal reacts with other gases, it forms some film on the metal surface. The corrosion depends upon the protective layer. Corrosion depends upon the formation protecting a non-protective layer with metal surface. Depends upon these films only. If these metal films are stable, then the further attack will be not takes place. If these metal films forms unstable products, then it undergo corrosion. If the film formation is protective or non-porous, if the thin film formed by these gases is protective or non-porous, what happens we'll see. The intensity of corrosion decreases because of the film formed will protect the metal from the further corrosion. If the film formed by the other gases is protective or non-porous, then further attack of these gases will decrease, and this metal will not undergo corrosion further. This is called if the film formation is protective or non-porous. Example, AgCl film resulting from the attack of Cl2 on Ag. Ag, this is a silver metal, reacts with chlorine, it forms AgCl film. This AgCl film is stable and non-porous. It will not allow the further chlorine to attack on this metal. Second one is if the film formation is non-protective or porous. If the film formation is non-protective or porous, this is the film formed by some other gases. This is the film. So this film is non-protective or it contains porous. What happens? The surface of the bowl gradually destroyed. Example, dry chlorine gas attacks on the tin, forming SnCl4. This is tin metal, reacts with chlorine, it forms one film like tin tetrachloride. Okay, this is non-protective and porous, it contains porous. So further chlorine reacts with this metal. The chlorine goes to this pores and reacts with this remaining metal surface, and the total metal undergo corrosion. Third one is liquid metal corrosion. What is the liquid metal corrosion? We'll see. This is due to the chemical action of flowing liquid metal at high temperatures on the solid or metal or alloy. Such corrosion occur in devices using nuclear power. This is the metal is there at higher temperature. If the fluid flow on this metal, then this metal undergo corrosion. That is called liquid metal corrosion. This is due to the chemical action of flowing liquid and metal at high temperature on the solid metal or alloy. Such corrosion occurs in devices using nuclear power. This liquid metal corrosion we'll see in the nuclear power. The corrosion reaction involves in the either dissolution of solid metal by the liquid metal or internal penetration of the liquid metal into the solid metal. If the dissolution of solid metal by the liquid metal, if liquid metal flowing on this solid metal, the corrosion takes place on this metal surface. This corroded part dissolved in this liquid metal, then dissolution of solid metal takes place. The second one is internal penetration of the liquid metal into the solid metal. This is solid metal is there. The liquid metal flowing on this metal, the liquid metal penetration into this metal, solid metal, and undergo corrosion. This metal surface undergo corrosion. Example, coolant. The sodium metal leads to the corrosion of the cadmium in the nuclear reactors. In the nuclear reactors, cadmium is corroded by this sodium metal. This is an example for liquid metal corrosion. Pilling bedworth rule. What is pilling bedworth rule? You see, the extent of corrosive effect depends upon mainly on the chemical affinity between the metal and gas involved. What is the pilling bedworth rule? The extent of corrosion. The extent of corrosion depends upon the affinity between the metal and the gas. Okay. The degree of attack depends. The degree of attack or degree of corrosion. Degree of corrosion depends on the formation of protective or non-protective films on the metal surface, which is explained on the base of the pilling bedworth rule. What is pilling bedworth rule? Says the degree of corrosion depends upon the protective or non-protective films on the metal surface. Metal surface reacts with gases, forms some protective or non-protecting films on the metal surfaces. The degree of corrosion depends upon these protective or non-protecting films. It is expressed in terms of specific volume ratio. The pilling bedworth rule explained the corrosion, degree of corrosion based on the specific volume ratio. What is the specific volume ratio? What is the specific volume ratio? It is the ratio of volume of metal oxide layer and volume of parent metal. There is a metal, it forms film on the metal surface. What is the specific volume ratio? It is the ratio of volume of metal oxide layer. This corroded part is called metal oxide layer. The volume of this metal oxide layer divided by volume of parent metal, the volume of total metal. It gives the specific volume ratio. Smaller the specific volume ratio, greater is the oxidation corrosion. If the specific volume ratio is less, then the oxidation corrosion value is more. If the specific volume ratio is less, then greater is the oxidation corrosion in that metal. Example, the specific volume ratios of tungsten, chromium and nickel are: the tungsten specific volume ratio is 3.6, chromium specific volume ratio is 2.0 and nickel specific volume is 1.6. Then the rate of corrosion is least in tungsten. Means tungsten contain highest specific volume ratio, that contain least that contain least oxidation corrosion. If volume of metal oxide formed on the surface of the metal is more than or equal to the volume of metal from which it is formed, the oxide layer will be protective or non-porous. What is given? If volume of metal oxide is formed on the surface of metal is more than or equal to the volume of the metal. This is a metal. It formed some metal oxide film. If the metal oxide formed on the surface of a metal is more, this volume is more or equal compared with the volume of metal. This volume is more or equal to compared with the metal, then equal or compared with formed, the oxide layer will be protective and non-porous. Then the oxide layer formed is protective or non-porous. When it non-porous or porous, the volume of this metal oxide is more or equal to the metal surface of the volume of the metal surface. Then this layer is called protective or non-porous layer. If volume of metal oxide formed on the surface of metal is less than the volume of the metal from which it is formed, the oxide layer will be protective or non-porous. This is metal is there. If it forms some metal oxide, the volume of this metal oxide is less than, or the volume of the metal oxide formed is surface of metal less than the volume of the this metal. The volume of metal oxide is less than the volume of metal, then it forms it forms some layer is called, that layer is called non-protective or porous. Non-protective or porous. What is given? If the volume of metal oxide is greater than or equal to volume of metal, then the film formed by the oxide is porous or protective. If the volume of metal oxide is less than volume of metal, then the thin film formed by the oxide is non-porous and porous, that is porous and non-protective. This is explained by the Pilling-Bedworth rule. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.